Okay. Okay, I prepared my console. You can see that R is like a calculator, no? I am going to show you a small set of sentences that you need to know for be working with R, okay? The first one now is a small introduction to R, okay? Very quick. The first one is C. C is very important letter in R because C is like a cycle. And this one is necessary when you want to introduce a vector. For instance, this one, okay? When I put this one, then it's the same that you consider a vector 1 and 2, okay? But I need to put this letter C if I want to recognize, because if really if I want to put this one, it's not going to be recognized, okay? This maybe is the most important that you need to know in R, okay? But first of all, it's important to remark that it's a calculator. You can do a sum or each operator that you want. And for instance, sinus, of course, you can do what do you want to do. Okay, it's a calculator. But the most interesting of R is to consider as a package for statistical. Okay, then
can you do full screen of this R? Is it possible to put full screen?
Okay, yes, it's possible. Now it's better.
Yes.
Okay, then you can see when I put I have this you can use as a calculator, like it's exactly the same that you know, but the difference that with, for instance, MATLAB is that the object, important word, object in R and are from statistical. Okay, then from a statistical point of view, vector that I will remark, vector have to be introduced using C, no? This one, when I want to put a vector for statistical procedures from the cache memory of the calculator, you are considering a sample always. Then the concept of vector from mathematics is not correct, okay? In R, the concept of vector is like the concept of sample. Then for R, when I put 1, 2, 3, you say that you observe 1, 2, 3. And in some sense, if you need to observe more data, you are going to increase this vector. Then the dimension of the vector and etc. Some mathematical concepts have to be removed of your mean when you are working with R, okay? You have to be your mean that C is a vector in the sense as a different observation of the same random variable. In this sense, it's important because I can do some operation, for instance, like this one. Of course, from a mathematical point of view, you cannot do this operation because it's 1, 2, 3, 3 dimension, 2 dimension. From a mathematical point of view, you cannot do it, but from R, you can do it. Of course, a warning message can appear, but the operation is done. You can see. The operation is done because consider 1 plus 1, 2 plus 2, and 3 plus, there are nothing, then it's a cycle, consider 1. Okay? Then it's important to remark this property because this C denotes cycle, denotes sample, and denotes a set of observation that if you need, you are going to repeat. Okay, this is the main difference from math. From when you are thinking from MATLAB, for instance, or you have some idea from numerical process. In R, the main object is based on a sample. The main object is based on 2 observations. Okay, then. For instance, if you want to do some, you want to multiply, for instance, vectors, you can see, for instance, now I am going to multiply. Of course, I can do it with 3 and 2 dimensions, but now focus on this symbol of multiply. Multiply is component by component. Is 1 for 1, 2 by 2, 3 by 4. because the natural product from a sample is to combine each observation of each individual, because the idea is each position corresponds to one individual. Then the first position is one individual. This one position is a response of another sample of another random variable from the same individual. Then the operation, the natural operation, is in this sense, okay? And all the operation in the same way. Then in some sense, 3 by 4 is clear, and you can extend from natural way from a statistical point of view when 3 is a set of observation of some random variable and 4 is a set of observation of some random variable. Then you multiply component by component, okay? Of course, it's a calculator, a complete calculator, and then you can consider different products with changing this operator, okay? But the operation for by default plus multiply and etc. are based in this sense of samples, okay? You have to take it upon this structure. Another important function that you need to know from R is class. Class is a function such that return the type of the object that you are using, okay? For instance, when I put, you can see I am going to scroll and I can recover, okay? The set of the instructions that I put. Suppose that I put X and assign this set of observations, no? Now X correspond to this one. Now X is in memory, I can recover X, and the class of X, you can see is numeric. Because remember that X, I can assign only one or a set. In each case, always class, you can see if I only put, if I only put X is 2, the class of X again is numeric. It's not different because the class remark, which is the type of the object, take it into account that this object can be repeat with different observation of the same event, the same random variable, okay? There are some main types of object that you need to know. Numeric, you can see when you introduce numeric, and it's not different with double or another type of precision. Character, when you, for instance, consider a letter, no? Then class is a character. And take into account that when you consider that, for instance, X is a set of observation, and this observation combine different types, then you can see X recover the type such that include every one of them. Then one now is not a number, is a character too. If I see which is a class is character, okay? It's important because you have to put in your mind that an object in here, when you consider a vector, is a set of observations, then you need to put only one class, only one type of variable. Then if I say that X, I observe 1 and A, I only can suppose that my random variable take character values, okay? This is important to take into account because many functions in R that you can, because it's typically that you need to do something you are looking for in Google and you copy paste some instructions and etc. And you have some problems because you need to identify which is a class of the object if you want to operate with them. Then it's important to consider this option class in order to identify exactly which is your object, okay? I am going to show some different examples in order to understand which is the different types that you can consider. Of course, when you are working with data set, you are not going to introduce number by number. Of course, you need to read some data, no? Then I prepare because I prepare these small instructions. This one set WD is working directory, is an instruction if you want to introduce where is your working directory. When you are working with R or with when you want to do a project, you need to fix which is the working directory. Then now, for instance, I am going to put my working directory, okay? And this is the path that the memory of the session is going to looking for the files, put my results and etc. Okay, it's very important when you start a project, you fix which is your working directory. In this working directory, for instance, in my case, is a folder in my computer, and I have some files. For instance, for example, this one is an example. .txt, you can see. Then when I go to my folder, I consider another instruction in order to read my file. Okay. You can let me to show some details. Read table is one of the most useful instruction function to read some data. And read table, the main advantage is because you can read all types of files. Okay, in general, I say all types, and really there are some types of files that it's so difficult to read with table, but the idea is you have several different arguments that you can put in order to understand which is the structure of this one. For instance, I can read some data, and I decide to start to read in some line, and I read to decide with some parameters. I can put, I only want to read 1,000 files and etc. A lot of parameters for this function. In this example, for instance, I want to read this file, example.txt, and I remark that the header of the columns is true. When I want to say true in R, I only need to put T, and I want to put false, I only need to put F, okay? Then with this sentence, I remark that my data, the data in this file include the header, then it's going to take into account. Then, for instance, you can see the result that I assign, the result of the function I assigned in a data with a name data. It's not too much original, but it's okay. And you can see my data, okay? Of course, when I put this sentence, the data set is including data, and one option in order to check if your read is okay is to consider head. Head is going to show only the first part of the table, and you can see, for instance, my table with my data. I have this 6 column: edad, gender, height, weight, and tobacco, if it's smoke or not, and TV, number of hours of TV that you see every day or every week, sorry, because it's too much. And this is an example, only an example, and head led to show, for instance, if I only want to see the first one, and then I can check that the read is okay. And I check that my read is okay, and remark that you can consider additional parameters, for instance, to say if the decimals have to be considered with a point, with a column, or if the separate of the different registers I consider with some symbol or etc. You can check this instruction of read table for more options. And another one very useful is read point CCV. Read point CCV is very useful because you know that several data sets are saved in this format. That read CCV are going to start to working with some data sets in this format automatically, okay? I put an example on this type of files too. Let me to work with this one, because I want to show some more details on R in general. Now you can see I have some elements because I say X, I saved X. You remember that I put X is this one, and data, you know, I have several data. It's a big data set, and I can check some properties. For instance, dimension. Dimension is very important property because remark that I have, you can see 545 rows, sorry, rows, 540 rows and 6 columns. And you have to take into account that when you are working in statistical, the rows are individuals and columns are variables, no? Then if your format is different, you need to consider some manipulation of the data. And of course, exist a lot of functions and a lot of packages that you can use to improve your presentation of the data. I am not going to show you with strong details on programmation in R, only this one, because if you never be working, this one is enough in order to start to do something. But of course, if you want to do some more advanced project, you need to know more advanced functions around to manipulate data sets, okay? Now, data set is perfectly structured because I have different rows. Each row corresponds to observe some individual, and for each individual, measure different properties. No, the age, the gender, etc. What you can do with the data? You can do an easy analysis. For instance, is a summary. Let to summarize the main statistics of some object. If I put summary data, then summary need to do a summary of an object type data. Let me to show which is, and now I am going to show, but let me to check which is the class of data. Data is an object that I create when I read, okay? The name of data is because I decide to put data, but I can put that you prefer, of course. It's only the name of the variable for my project, okay? Then the class is data frame. This is the most important one type of object in R, because the data frame is the structure, the natural structure from a statistical model when rows are individuals and columns are as a set of observation of some random variables, okay? This is the typical structure when you want to do some statistics. Remark when your data is not really structured with this form and you read table, R understand automatically that is that data frame. If your data is not good organized, data is going to be working maybe with doing that you want to do, but be careful, because if you use read table, it will, because you know that the data correspond to a data frame, okay? It's your responsibility, because really R is not going to take into account if you put some data without data frame structure, okay? Then read table, if it's okay, return data frame, and now R is going to understand that rows, individuals, columns, variables. And when I say summary, data, is going to do some summary of this type of data. Then you can see data. The first column is age, and age is a numerical. Mean, median, first quantile, and third quantile, you can see. But for instance, when read gender, data recognize that is a character, and then remark, this is a character, and you can decide which is the pattern that you want to use. And it's not going to show this type of summary. Then R is going to decide the type of the summary in function that you decide which is the type of the random variable, okay? Then you can see in this one, recognize summary, that summary as a numeric, it's okay. And in this case, for instance, when you want to check this one, you need to say, be careful, because gender, you see character, and I want to say this is a variable with two values, woman and men, no? Then I had to say, if I want to do this one, I need to do some information with this column. How I can get some information on this one, on the data? You see, again, I show head of data. Remember, it's the first 6 rows. You can see, for instance, 6.2 is a position, second row, the first column, no? Then data with this symbol. If I say 2, 3, with this notation, R is going to identify the number or the value in a second row and 3rd column. And you can see is this one, okay? Then if you want to be accessed in some position of the table, you can consider as a matrix. Of course, this matrix the label of the row. This is a label of the row, 1, 2, 3, is a label. And the label of the column, these words, is not going to appear. You can see. The matrix, a data frame, when it's considered as a matrix, only consider the information inside, okay? Then you can consider some information. If you want to consider, for instance, one column, you can say nothing in the row, and for instance, say 1 or 2, I don't know. Then with this instruction, you say, I want to recover all the values in the second column. Then I am going to see all the values in the second column. Then you can see H, H, D, H, D, H, H, D, H, D, okay? You can see when you show in a screen the different values, you have some reference in here, indicate the position of each one. It's only in the order you understand the data, because say I start by 1 and I remark that this one is the 19, this one is the 37, etc. But these numbers doesn't matter, because it's only to understand the screen, the print screen, okay? Then this one data, the second column of data, you can recover all the data, this one corresponding exactly to the values inside the matrix, okay, without the labels. No labels for row, no labels for column. Another way for this one, you can see using this expression, you can access from data frame as a matrix, but you can take information of data frame as a data frame. Then I am going to use this symbol. This symbol, if I put, remember I have different columns. If I put data, dollar, with that, no, or for instance, again, gender. If I put this one, I am going to recover again the same than before. You can see data género is the second column. Okay, with this I access to the information as a data frame, and previously when I do this one, I access to the data frame as a matrix object. Okay, because data frame for you have to be in your mean is a matrix plus some labels for rows and some labels for columns, and labels for rows are individuals and labels for columns correspond to random variables. Okay. Okay, then what you can do with a data frame? Statistical modeling is the first one, no? But the typical is to do some plot data. Again, plot is an intelligence function, and sometimes when you put an object from data frame, if it's possible, try to plot all that you can do. Now you cannot see, I think. You see my plot? No. You cannot see. Okay. One moment. Let me to show. You can see this one, this object. This is a plot where each variable, you can see, each column of my data set is plot from the other one. For instance, this one is gender with 8. You can see, and etc. Okay. It's interesting to do an exhaustive some exploration, because, for instance, is an example. I show only this data set, and because it's from didactic point of view, it's interesting because, for instance, you can see gender. You can see identify a lot of points in here, a lot of points in here are some different points. Then it's detecting that maybe gender is not good codified. Maybe there are some problems with the codification. Okay, then I need to review, because you can see gender, I suppose is woman and men, but I see take 4 values. Okay, and you can see with another one. More interesting things is when, for instance, when you relate peso y altura, you can see a plot, but you can show this, for instance, this plot. For instance, if you take plot and you do data, peso, and data, altura, I am going to obtain the plot that I show very, very small now, more clear, no? Now you can see this plot where you can check each point correspond to one individual with the peso versus altura, no? This is the most easy plot that you can do, but very useful, I think, because many times it's enough in order to recognize some things. But okay, the first exploration, when you see this one, you say, okay, maybe I have a problem with gender, no? Género. Then table, let to summarize variable when it's a factor, no? Because gender really is a factor. Then if I consider this one.
Can you do full screen again, that it becomes?
Yes. It's complicated. Okay, you can see now, you can see table let to do a summary when it's non-numeric. In this case, you can see D, H. This is a problem, no? Because it's not good codified. In fact, I can see some letters in here, but I am not going to look for, of course. Then the most easy is I am going to remove, for instance, this one because I have to put this one, no? What I can do? Let me show this one as an example. You can see what I want to do. I want to put in data, in the column género, when data in the column género is equal, and be careful, 2 equals, because it's a condition. 2 equals is because of a condition. When I want to put different, I have to put this one. This is different, okay? This is different. This one is equal. Then if data género is equal to B, no? Then I need to assume D, no? Is that I need to see. Then if I repeat, you can see I remove D. And again, I am going to say when in data appear H, really I need to put H. Then now the table is okay. And of course, if I repeat the plot, I am not going to do because I have to change the screen. But if I repeat the plot, then it's more clear because this variable is going to be considered as a factor. If really I want my data set to recognize that have a factor, género, I can do this one. I can do the data género. Okay. I want to assign factor of data género. With the word factor, I transform the information in here with a random variable as factor, then recognize that the values, each value correspond a value of the random variable. Then now if you do a summary, you can see, remember previously say género is character, and now say no, género is a variable, is a factor, then I have to do a table. Then summary of you can see, when you do summary is like an intelligent function because recognize when you need a summary as a numerical or a summary because it's in this case, a factor, because I say it's factor, okay? Okay, this is a small summary to start working with that. And now I am going to do a small model, okay? If it's okay for you, that I want to do is when I have data, peso, I am going to say X, okay? Is my X random variable, and altura. And altura, which will be the response. Suppose that I want to model altura using peso, okay? It's the most easy that I can do. Then plot, I am going to plot X with A, and sorry, I don't know. Sorry, plot. plot. I do plot XA. You cannot see the plot, but it's the same than before. Do you remember? It's the same. Only I changed data peso because I now put X and I as a response in order to show more easy examples. Okay. For me now, I forget data set. I am only focusing 2 columns. I want to model the column altura with a column peso. Okay. Then is the most easy that you can do is a linear model. So, okay, maybe you want to. For me, it's interesting that you can see the plot, but this that I am going to first I am going to put some formulation and then I am going to show. Okay, the full screen. Linear model is a linear regression that you know is to consider the linear regression in order to fit the response with some information, no? And the formulation we had is this one. Is the most easy. The most easy one is this one. This is the most easy model. Really, it's not the most easy model because really you can do some another more easy too. But with this only one instruction, I can do the linear regression. This is the result of linear regression. Let me to show the result in here, say that my response is equal to this value plus this value multiplied by the value of X. Okay. This the one is the independent term, and this is the slope of the line. Okay. Then it's very easy linear regression when you want to compute, but let me to show some details. I can say the result of linear model with some good mod. Sorry, I always put mod like a model. Mod correspond to all the information in this process. If I do summary, again, summary is an intelligent function, and I say mod, then mod, the type of mod, the class, if you want, you can consult, you can check which is the class. When I do class of mod, detect that mod is the output of a linear model. Then when I do summary of mod, it's going to report a summary of this type of objects. And the type of object that linear model is this one. And where you can see, this is all the summary of a linear model, okay? You can see again the intercept, the independent term of the line is the same than before. This is the slope, but the most interesting is this set of numbers where some testing, some statistical testings are produced. In this case, for instance, you can see that this one, this number, the result in this one is doing a t-test. T-test correspond to compare as the mean. If the mean is equal to 0, the p-value corresponding to this test is really small, then you can reject that this number is 0. Because remember that in statistics, when you observe some statistic as a random variable, you need to measure the uncertainty around. Then this number, the uncertainty is in here, described with the standard error. This number, the uncertainty is described with this number, the standard error. And with this check, with this test, you check if you have to consider the possibility such that this one or this one is 0, okay? And you can see in both cases are different to 0, then the model in this case is finished, linear model. And moreover, you can check another properties, for instance, R squared, that you can see this one, close to 50%, corresponding to say, with X, introducing X in order to explain the response, you obtain a 50% of the variability explained, okay? I don't know if it's very clear for you, this concept, but you can see my response, this one, has a mean, no? You remember this one is altura, it's a set of numbers and has a mean, and has a variance. This is the total variance. If you are asking me, which is the, this is when you ask, let me know which is the altura, I am going to say this number. If you say, sorry, let me know the altura when you know the peso. If you know peso, you know X, of course, I am going to reduce the variability. When I don't have X, the total variability is this one. When I know X, the total variability is reduced in 50%, because 50% of this variability is explained by the model. Okay? You can see this one using the residuals. If you consider the residuals of the model, the difference between the fit using liner with the liner and the real value, and you check which is the variability, you can see that is exactly the 50% of this one. You can see this one using ANOVA. If you do ANOVA of the model, you can see ANOVA is checking the variability, and you can see the sum square, the total sum square is this one and this one. And with X, you explain this one. Okay, sum square, this is the total sum square. Total sum square, let me to show the number exactly, is when I do sum of A, the response, minus mean of A, the trivial model, no? Trivial model is, let me to show you. If I consider each observation minus the mean, you can see mean is the response that you say when you don't know X, when you don't know X, if you don't know the peso, the altura is the mean. And then each observation minus the mean, the difference square, and I do the sum square, the total sum square is this number. Then it's the total sum square. Really, it's typical notation total sum square, okay? When I start, total sum square is this number, okay? Total sum square. When I consider a model, linear model or neural network, it doesn't matter. When I consider a model, I am going to take something where I can put in here. I am going to remove mean because I am going to improve the model using something in here. For instance, in this case, I am going to put this one plus 0.63 multiplied by X. No, I don't remember exactly the number, so something like this, no? This one and this one. Then I am going to put this one, it's not exactly because it's some decimals, but when I put this one, you can see each individual in here minus the corresponding value for the model. In this case, the model is linear model. The difference, this difference, square, if I do the sum, I am going to obtain a different number, of course, because I am going to reduce the total. Initially, I have a total sum square. When I do this one, when I improve the model, because this model is too much simple, because we consider X, I am going to improve. I reduce the sum square. And you can see this number is this one. Okay, sorry, is this one. Okay, but some difference with the decimals because I not put exactly, okay? Then this one is the residuals. This residual, this sum square is this one. And the explained part is this one, that this one and this one, if you consider this plus, sorry, plus, plus the other one, you obtain the total sum square, no? Then this one plus this one is total sum square corresponding to consider the mean. And when you do the linear regression in this case, you consider a improved model, and then you have some residual, some non-explained part, but another part is explained. And you can check if you explain enough with an F test from Fisher, okay? You can, with Fisher test, you can compare if this improvement is enough. And of course, you can see 50% is it's really as an improvement. Really, this test, NOVA is interesting when it's not too much clear if this one is an improve of the model, okay? But for instance, anyone can use to compare different models, and you decide if the variance, the different variance that you explain is enough for consider different models. Then these concepts are very important. You can see from linear regression, you can check different parts. Total sum square always is the reference, and residual sum square will be different depending on the model. If I put linear, you can see I can use a neural network, then it's going to be changed, okay? I don't know if I can start with linear regression. With neural network. Maybe it's let me. Can I start with a neural network for compare?
Yes, 10 minutes.
Okay, that I am going to do is to show with the slides because it's more quick, okay? And then if we can use again here. Okay, remember these concepts? Then I show. Let me to start with, you can see. You can see, but okay, I want to introduce neural networks, putting your mean that I was comment around total sum square and etc. as a model. Then now the most important, from a statistical point of view, I can talk again from linear model and additional models, but for now it's very easy model, regression, or for the most easy mean without X, without information.
Will be
When
possible to put full screen the slides because it appears small.
You can see my slide now.
Yeah, but small. If you can put full screen. Yeah, we can see, but it's it's a third of
It's not okay. I was thinking that you can see now better.
Yes.
Yeah.
Yes, thanks.
Yeah. Okay. Okay, putting your mean that when you have linear regression, no, or the most easy, without information, mean, no, the response mean is the mean of the variable. When I have some information, I can improve this mean. In your head, it's clear that that I attempt to model the expected value, okay? Take into account, because always when I explain, that I always explain in the first day, I am thinking that my process for modeling is in order to predict or model expected value, okay? But I can change this one, but this is the most easy example. But you can change the property of the uncertainty, but typically when you want to describe uncertainty, you are going to talk about expected value or variance. Then in general, all the results in statistical learning is based on this one, no? Then again, in this taking into account this constraint that I am going to focus in to compute the measure of uncertainty as expected value. The most easy is the mean sample. When I introduce information, I can do a linear regression, but of course I can do a neural networks or another models, okay? Very quick, I am going to pass. I think the next day I'm going to talk with more details about neural network, maybe, because I want to focus in the formulation. But remember, I don't know, so I am sure that you know something about neural network because everybody knows today. But I think it's important to be thinking that when you are doing a neural network, a model of neural network, you are trying to emulate the human brain. It's important to understand because it's a way to understand the complexity of the process, okay? But in general, a neural network corresponds, you have an input. Input is information, and you process information with your head, with a real neurons, no, or with artificial neurons, and you get an output. And this output attempt to model some expectation of some random uncertainty procedures. In this process, really only two components in general: linear combination that really can be more extended from a mathematical point of view to operators, but for now, linear combinations, and activation functions. Activation function is very important because it's a key point where from machine learning, theoretical machine learning, you can recognize that with some small constraints of a function that you attempt to model, you can be sure that with some activation function, you can get a good model with neural networks. based on the theorem of universal approximation. Okay. But now I am not going to talk too much about that, only to show some small structure of the neural network. For instance, in this one, you have to put in your mind the idea of neural network where the input layer is a set of neurons, and each neuron have to be understood as a column of your data set. Okay, in this neuron, for instance, you put peso, altura, and etc. Of course, if I want to put altura as a response, I am not going to put altura in here. Peso, gender, etc. And for instance, output layer, if you have output numerical with only one, if your output layer, if your response is, for instance, 0, 1, you need 2 neurons, okay? One for to detect zeros and another neuron for to detect 1. The formulation of the neural network really is not too much complex, but you need to understand some components. Now I am going to show an example. I come back here, okay? I put some slides, and you can see previously of the next day. Then you can ask me if you need something. But now let me to show this example with ozone. Ozone is a data set talking on, ozone is a data set, ozone, with some, you can see summary of ozone with different columns. Ozone is a level of ozone, of course. And for instance, you have some information on the humidity, temperature, wind, and etc. And the idea is to try to use all this data in order to model ozone, the level of ozone. Okay, this one, O3. O3 is the response, and I want to model O3 with all data, okay? I want to show an easy library, NNet, which I don't know which, NNet, library NNet is a library of R that you need if you want to consider this function, NNet. Now it's not important, and really exist several packages more powerful when you want to do some strong projects. But for now, if you never was working in this one, start with these easy libraries, because you can understand really which is the process, okay? Then you can see in net, I want to remark this expression. Now I want to do an easy example, okay? In example, I put nnet response, the symbol again that I was using with linear model, and the variables that I am going to consider using plus for identify. You can see this expression I want to remark is exactly the same than before. The difference is because I say I want to do a linear model and put LM, and now I want to do an nnet, okay? From R project is based to understand the process of modeling based on uncertainty modeling, then is not different the formulation for this one, respect and standard formulation. Then always is response, the symbol, and the covariates, the information that you are going to consider. In this example, you can see we are going to model ozone using temperature, EVH, and EVT, okay? More details on this one you can see in Google easily, because ozone is a typical example from didactic from to understand modeling. Then a lot of information on this data set. And in this case, but in any case, in R you can, if you ask help, you should put help ozone, you are going to obtain some additional information of the data, okay? And now I am not going to talk on that. Only want to show some big details, okay? Then the formulation, the same than before. I am not going to put LM, I put nnet, some additional parameters that I am not going to explain now, only want to focus on this one. And the result that I want to show is the result of the model, okay? The result of the model, you can see total sum square that I show is a sum, remember, of the response minus the mean of the response square, no? Sum square, the total sum square. Total sum square, then in our case, in the case of ozone, total sum square is this number. You can see 21,000 is a total sum square. Then in your mean, you have to put that this is the number with the worst case. If I consider a linear model, no, LM, and I consider ozone, and I consider this symbol again, and put these three variables, the result of this LM is going to produce some number in here multiplied by temperature plus some number in here multiplied by this one plus some number multiplied by this one. Then with linear combination of these three, I am going to fit this one, and the result I am going to check, which is a residual sum square. The residual sum square, remember, is a prediction. No, you can see predict is a function in R, and it's more easy because otherwise you can put exactly the formulation, the numbers, the corresponding numbers, but you can use predict, and then you don't need to do, okay? With predict, it's the same that I was showing with the previous example, okay? And then when I check which is the residual sum square of the model, I obtain this number. Then you can see the residual sum square is 7,000, previously 21,000. Then you can see that you can explain the variability, the total variability of ozone using linear model. You can explain more than, I don't know, 50 or more than 10,000, no? Because the difference between this one and this one is that you can explain using linear model and this information, okay? However, when you consider residual sum square with the NNet, no, where you consider ozone and predict with a model of ozone using NNet, using a neural network, is terrific because the residual is like previously. You can see with linear model, you explain a lot. With neural network, you don't explain because you have 21.1 and 21.0. You really not explain. With a neural network, in this case, you cannot explain nothing. The reason is because, in fact, remark that this number you can recover from horizon from the model, okay? You can recover as a parameter of the model. But if you want to compare the residual sum square that you explain with a linear model, you explain a 65%, and with a neural network, you explain a 0.0007. Okay, this is a percentage, okay? Because it's the part that you explain over the total sum square, the part that you explain over total sum square. In linear model and a neural network. In this case, you explain 65%, and in this case, you explain 0%. This example is in order to understand the first idea that I want to finish today with this idea that more strong modeling have to be careful because this one is typical. You need really consider a very good architecture in a neural network if you want to obtain improved results from, for instance, from a linear model. Linear model is very white box model, and it's easy to understand what you have to do in order to improve. With a neural network, you have to be very carefully, okay, when you want to check. Then now today is a very terrific example of neural network to start, but it's interesting to remark where easy way to compare the improvement of the models, okay. I think I can finish with this one today. Let me know if you have some questions or comments, but the next day I propose to continue with neural network with more details with this one, and maybe with some another example of modeling between linear model and neural networks, for instance, random forest. But I am not sure that I can explain too much modeling, but I am going to try. Okay, if you want to know some details from the next day, let me know because it's the last session, and if you have some exact question, let me know. Okay.
Yes, thank you very much. So let's thank Frank. Yes, if you can send some material so they can read, something.
Okay. Yes, yes, yes.
That-
Yes, this weekend I can I can recover. Okay.
Okay. Thank
Thank
you
you.
very much. Very
Bye.
clear. Thank you. Thank you
Thank
so much.
you. Bye.
Bye. Espera. Espera.